Hey, welcome back, everybody. We are going to move on. AP's over, but hey, your tax dollars went to learn an AB Calc, and let's make sure you get your money's worth before you go off to virtual college in the fall from your basement. So let's just take a look here. Nothing too big. Something you could probably figure out on your own here. Talking about area between curves, chapter 6, the last small unit here. And this really shouldn't be too bad. We're going to try to find the area of the region that is bound by these two graphs. We have a parabola opening downward here, that's f of x, and the line y equals 3. Okay, so you know how to find the area underneath the curve. That's by integrating. But for example, integrating f would give you the area all the way down to the x-axis. So I really want to do a couple things. One, I don't want it to go all the way down to the x-axis, so I've got to take out this area that's underneath the line. And I got to know, well, what are these boundaries? What x values are the boundaries of the region? So that's the first thing I'm going to do. Let's find where these points are. And that would be by finding the intersection between these two graphs. So I'm going to set this equal to 3. And if I were doing this with a graphing calculator, I could do intersect feature. This seems like an Algebra 1 kind of question. I should be able to do this. I can definitely take out a 3 or a negative 3 if you like. And we get a nice quadratic that factors. Oh, will you look at that? What are the chances? Factors down to that, so our solutions are x equals 3 and x equals negative 1. So that is happening when x is negative 1, and that is happening when x is positive 3 right there. And so I just want this region. Okay, so I'm going to set up an integral, obviously, to find area. And you could either do two separate integrals, one for the parabola between negative 1 and 3 and find the area all the way down to the x-axis, and then set up a second one for the area of the second curve and subtract out the area that you don't want, that's part of it. I'm going to set up one big one, and this can always be accomplished here. Same deal though, we are going from negative 1 to 3. And if you have two curves, just keep in mind, you're going between this curve and this curve. And if you think back to when we found area with integration, or even before that when we were doing Riemann sums, it was really just a bunch of infinitely thin rectangles. And you were essentially adding up these heights, and the heights were just these y values. Well, now these heights of this region are really the difference between these y values. And so since you're talking about a distance always being a positive thing, you always want to do the top y value minus the bottom y value. Or in this case, for this entire region, the top curve minus the bottom curve. So that's really the big thing. You want the area trapped between these two. I'm going to set up one big integral of the top curve, and then I'm going to subtract out the bottom region. And the bottom in this case is just 3, but it really could be any graph. It could be any funky thing here, and I would subtract it out. Of course, got to have your differential on the end there. Just because the AP exam's over doesn't mean we don't care about being proper math students. We're not cavemen here. And so this, could we integrate this by hand? Of course we could. We're professionals, but how about we use a little calculator action? And so we'll go back to the home screen here. Math 9, maybe you've forgotten where these buttons were because didn't need them on this year's, but we're going from negative 1 to 3 of negative 3x squared plus 6x plus 12 minus 3, or you know what, I can do that one on my own. That's plus 9 with respect to x. You get 32 on the dot. Amazing. 32. So, just to summarize that, if you're finding the area between two curves, The limits of integration are those intersection points or the boundaries of the region from A to B, and you always want to do the top minus the bottom. Again, and that doesn't matter whether you're below the x-axis, above the x-axis, one's above, one's below. To find the vertical distance between 2 points, you would always do the top y value minus the bottom y value. And so that's why it's that. Very nice and easy. And how about just one more example? Got to get your money's worth here. But if you want, you could live life on the edge and pause and see if you could do this one on your own, and then, check after. Or, maybe you've stopped listening by now. Who knows? But take a look. We're going to find the area of this region bound by these two graphs, and you may notice they intersect a couple of places. So there's really two regions, and they're not. They don't look to be the same size, at least. You have a line of 3x minus 4, and you have this cubic function here, x cubed minus 5x squared minus x plus 16. So I'm going to find these. I could definitely set them equal, and I could probably solve this algebraically. Not necessarily. You can get some really difficult cubic equations to solve. But I tell you what, let's go to the calculator here. So this unit, feel free to use your calculator, but I'm going to approach it the same way as the AP, meaning this is what you would do by hand. I'm just going to use the calculator to help me solve it, but you still write the equation, you communicate where you're getting these values from. So these two equations are equal for what x values, and I'll go to the calculator, put them in, hit graph. There it is. You might have to adjust your windows. I went negative 20 to 20 on the y-axis. Second trace, intersect. And remember, it's going to go to the closest one. There's 3, so it doesn't matter the order you find them in. They definitely intersect right here when x is 2. 2 on the dot. Very nice. Let's get the next one. Second trace, intersect, enter, enter, and it definitely intersects closer out here to 4 or 5. I don't know. Oh, we're at exactly a 5. Got a little ink on my calculator there. It's all right. It's a little war paint. And second trace, intersect, enter, enter. Definitely to the left here. Looks like maybe at negative 2. All right, so at negative 2 on the dot. And so here are our values. 2, 5, negative 2. Negative 2. This one occurred at positive 2. And this one occurred at positive 5. So we've got two regions, so we're going to set up two integrals. The first integral is going to go from negative 2 to 2. And we talked about the top minus the bottom. For this region, which curve is the top or upper boundary? That would be f of x, and this one is g of x. Okay, so for that one, you want to do f of x minus g of x. And yes, I could write the equations out, but I can also use this function notation and simply say f of x minus g of x plus the area of this region. And that region goes from 2 to 5. And the only difference is that they have flip-flopped as far as which one is the upper boundary. Now in this region, anywhere I draw a vertical line segment, right, the upper boundary is g of x and the lower boundary is f of x. G of x minus f of x dx, and now we'll use the calculator to get these values. And by the way, if you have reversed the, I don't know, if you have trouble visualizing what's upper and lower, what's top and what's bottom, and you reverse the two, you're going to get the negative value of the area, the opposite value. And this is area in the pure sense that it should always be positive regardless of where you're at, not the signed area of, when you evaluate a definite integral. So here we go. Now we can go all the way to the home screen, and if I got them in y1 and y2, I believe f of x was in y1, okay. Math 9, here we go. Math 9, from negative 2 to 2 of y1, alpha trace, y1 minus y2, dx, And why not just do another big one? Plus math 9, or if you like to get them separately and then add them, that's fine. Alpha trace, this time it's y2 minus y1. Close it. Oop. X. All right, final answer, 78.083, which would be acceptable. If you want to try to answer with a fraction, that's up to you. We'll go with a decimal though. 78.083. That's really the appropriate way there, to make two separate integrals when they reverse positions. But I will show you, this is kind of a cool trick, that instead of doing these two separate integrals, I could do this. I could go all the way from -2 to 5. So I'll set up a new one, and I'll go all the way from -2 to 5. And really, I just want I'm adding up these distances, essentially, these heights. And if I always want to ensure it's a positive quantity, then I could just do the absolute value of the difference between the two. And that way, regardless of which one's the upper, which one's the lower, I could. I mean, this is kind of cheating, but, you know, hey, why not? You're old enough now. You can know about it. So that would be under math. Num would be absolute value. And it doesn't really matter which one you put first. But it's nice to know. It's nice to really understand and visualize that. And of course, I'm going to get that 78.083, at least I'm hoping I am. And you'll notice with the absolute value, it does take it a little extra time to do it. So there you go. Very cool, right? Feel like you got your money's worth today. And so there you go. You got any questions? Not too much homework. Just give it a shot. Got any questions? Just ask, all right? Take it easy, kids. See you soon.